For the final section of the prerequisites for pre-calc, we'll be looking at modeling with equations, which is pretty much another way of saying we're looking at word problems. This can seem intimidating, and it definitely has its moments, but I think with the problem setup or the problem strategy that we have set up here, we'll definitely be able to use equations to solve problems, and a lot of these are in a real-world context, so there might be some areas where you can relate to what's going on. First, of course, we'll be reading the problem, and I'll zoom in so we can really highlight on these. We'll be reading the problem, which it seems like a basic thing, but sometimes this is the main step where if you don't follow through with it or you're not too sure exactly what you're reading, the rest of the steps are going to be pretty difficult to map out. So we'll read the problem. If we get stuck, and this might happen to me, so I'll reread the problem to make sure that I understand what's going on. To take this further, I'll be then identifying what's going on in the problem, taking away the information that I think is important, listing the information separately. If I have the space, I'll definitely make sure to do that. After listing all of the information, circling what's needed to actually solve the problem. So there might be some work here that's extra or extraneous, and half of the word problem might just be figuring out what you need and don't need. Drawing a picture when possible, I think, is helpful. Not all of the context will be able to really apply a picture, but if we can, we'll do that. Listing a goal, that's important because we might get lost in some little detail in the word problem and forget what's going on, but we'll make a goal that we think we can obtain and what we're being asked to solve for. Eventually getting to the actual math portion, or I consider this the actual math portion, because this is where we're actually making an equation using real words or eventually switching to numbers. So the last two are really where the math or your interpretation of the math might be. So if we start with this first problem here, let's read through this. So the selling price of a computer is $698, not too expensive. If the markup is 22% of the dealer's cost, what is the dealer's cost of the computer to the nearest dollar? So I'm going to reread this. So I know that I'm selling a computer, or there is a computer that's being sold. There's a certain markup. So if you're not too familiar with these terms, a markup is the profit that's being made. And that's 22% of the dealer's cost. So when you buy something in a retail environment, before you sell it, you have to get the dealer's cost. So you have to eventually spend a little bit of money to make the markup and make your profit and also make your money back from the cost. And we're being asked to find the dealer's cost of the computer to the nearest dollar. So we've read through the problem. Let's see if we can identify all of the information given in the word problem. I'll give you a moment to think out what's important in this problem. So on the side, let's make a list of what we think is important. So what do we think is important? Well, hopefully the selling price, which is $698. The markup. So the markup is 22% of the dealer's cost. And in addition to that, we're being asked to find out what the cost of the computer is. Okay, so we've identified what we needed. We'll circle this in the context so that we know. So the selling price is $698, the markup is 22%, and we're being asked to find the dealer's cost. To draw a picture, let's say that we have the computer. Let's make it a laptop, why not? So we know that when this is sold, this is eventually going to be $698. But we know that there's the dealer's cost, which is only a one-time fee that is paid. And how can we denote the markup? Because the dealer's cost, we definitely have to pay that, but how can we denote the markup? Well, we know that this is added on to the dealer's cost, and we know that this is also 22% of the dealer's cost, so let's call this the markup. And this is 22% of the dealer's cost. Okay, so we drew out a picture. Hopefully this is helpful. The goal that we should be stating in our own words is the cost of the computer. So let's make sure that that's our goal. So the dealer's cost. And that's what we're trying to find it. Okay, so if we set up an equation, we kind of have one mocked up here from the picture. Hopefully that helps. Where the total selling price of the computer, $698. This is equal to the dealer's cost, and adding on the markup that eventually equals the sale price. You can think of this if you worked in a retail environment. You have to eventually buy each item in store, but then you mark it up a little bit to then sell it at a higher cost. So if we set up an equation that shows this, we could say that this is the sell equal to the dealer's cost. And then how can we denote that markup using an equation development? Well, we know that the markup is 22% of the dealer's cost. So it's as if we have another form of the dealer's cost here, but now we have a fraction. And so you could say that this is 22% of the dealer's cost. In this case, I'm going to use decimals. So this is 0.22 of the dealer's cost. So this is another way that we can use percentages. It's by switching to decimals. And so what I did there was just switch the decimal, or sorry, switch from 22% to 0.22, which is the decimal. And so solving this, how can we break this equation down further? Or how can we start to simplify this? Well, we know that we have the dealer's cost and another form of the dealer's cost. Can we combine these somehow? Well, we have one form of it and then a percentage, so we could add these up and say that if we have one version of the dealer's cost and 22% of another dealer's cost, this should be equal to the selling price. So if we use numbers for this now, we said the selling price was $698. This is equal to 1.22 multiplying with the dealer's cost. How can we solve this equation? It should only take one step. How can we solve that? Well, I know that 1.22 is multiplying with the dealer's cost, so if I use division, so use opposites, dividing both sides, I can then say that if we have 698, and we're dividing by 1.22, the dealer's cost should be approximately $572 with 13 cents. So when we divided this, the dealer's cost is approximately 572.13. What units are going to make the most sense here? Hopefully you're saying dollars. So what we found here, again, as we mentioned, for our goal was to find the dealer's cost of the computer. This is the dealer's cost for the computer. We use the correct context using dollars. And in the next video, we'll see a few more examples of this. But this is definitely our final answer. So not too much of a markup on this, but I don't know. What do you think? Does this make sense to throw down $572 and then end up with $698?